so we need to solve this algebraic inequality, and we are going to solve it algebraically. So that means we are going to use our inverse operations on both sides of our equation. So I'm going to start by just putting a few organization pieces in, the bar down the middle, and then I'm going to circle the variable, and it's a term with the variable right here. And notice that I didn't just circle the 3x, I circled the minus sign in front. If you missed this problem, this could be what you missed, is this negative sign. It's a minus sign, but it's also a negative sign. This symbol goes with the coefficient. It doesn't go with the 2. The 2 is positive. It's always the symbol that indicates positive or negative is always to the left of the number itself. So that's key right there, is to identify that the term is negative 3x and we need to get the 2 away from it. So we are going to minus 2 on both sides of our inequality. That's the first step. That 2 should come back in a second. It just popped away for a second. If it doesn't, I'll rewrite it. Okay, there it is. All right, so we subtract 2 from both sides, and now you have 2 take away 2, that's 0. And on this side, you have 29 take away 2, that's 27. So we're just going to simplify by doing the math we wrote to get our negative 3x by itself. Because I didn't multiply or divide by a negative on both sides, my inequality stays the same direction. Now I'm going to bring this entire term down, including that negative in front. Negative 3x. So if you check your work, this might be where you missed. You forgot to include that minus sign on the 3. Okay, now we need to get x by itself, so I'm going to circle that x term again. And I will circle just the x this time. And my coefficient is a negative coefficient. So since it's a negative coefficient, I'm going to divide both sides by a negative 3. That way, both my 3 and my negative cancel. 3 divided by 3 is 1, and a negative divided by a negative is a positive. So this would make positive 1. On this side, I'm also going to divide by negative 3. And I get, simplify what we just did there. We get 1x or x. And on this side, I get a positive divided by a negative is a negative, negative 9. Now, here's the other thing we got to watch out for when we're dealing with equalities that we didn't have to watch out for when we were dealing with equations. We have this inequality symbol, and when we divided by a negative on both sides of our equation, we took the opposite of these numbers. They changed from a negative to a positive and a positive down to a negative. So they went opposite. When you multiply or divide by a negative, you're taking the opposite of the symbol you're given. So this symbol also needs to switch and do the opposite. And we get x is less than negative 9. So my endpoint is right here at negative 9. That's the endpoint. So I'm going to now need to do my graph. I've solved it algebraically, and I did that to find that endpoint. What's the highest or lowest number I can have for this inequality that will be my endpoint. Okay, so now I need to graph it. So I have my inequality, the original one. I don't want to use this one directly, because if I use this one directly and I've solved it incorrectly, I'm going to graph the incorrect graph. So I'm going to come back over here and I'm going to use this as my test point with 0, the original. So I might be able to get which direction is shading correct, even if I don't have the right endpoint. And I'm going to plug 0 in. And when I plug 0 in, I get 2 take away 0, which is 2. And my statement reads, 2 is greater than 29. And if that's true, which it is, then I know that I'm going to shade in the direction of 0. So now I'm going to make my graph. My endpoint is negative 9. Well, we're going to use the text tool. Use all the tools that I want you using for your graphs. So I'm just going to put in negative 9 for my endpoint. Cover up that other negative sign. Oops. Okay. Negative 9 for my endpoint. And I have to decide if negative 9 is a solution or is not. There's no equal bar on my inequality, so it is not a solution. So I need an open circle on that negative 9. And that means that it goes up to -9, but it doesn't include it. Now I know what number splits my graph into the solutions and the non-solutions. So now I need to decide which way to shade, and this test point tells me. So 0 is over here to the right of -9. So I'm going to shade in the direction of 0 because 0 made this inequality work. So I'm going to not put a circle, select the line tool. I'm going to shade to the right. And I'm not going to stop there. I'm going to put an arrow on the end of my shading to indicate that my shading continues just like the number line. And there you have it. Okay, now the next problem said describe in words all possible solutions for this algebraic inequality. Include key math terms in your response. So we're going to translate what this picture reads into words. And there's a lot of different ways you can translate this. So we are just going to inequality words. It's showing that -9 is the smallest number you can get. So you can say, and it can't be -9. So we can say that our solutions are any to this inequality. I'll just try to use a complete sentence here. To this inequality are all numbers bigger, greater than, bigger than, more than 0. I'm sorry, bigger than -9. Okay, so that's one way to say it. Our solution to this inequality are all numbers bigger than 9. You could say that -9, well, just you could say our solutions to this inequality are all numbers more than 9. Our solutions to this inequality are all numbers above -9. So the key math terms is using the word solutions in your description, inequality in your description, and then an inequality word like bigger than, more than, above to match what that graph is saying. And that's it.